Sora, and in today's video we will understand lightning impulse test of power transformer. So friend, whenever you see any transformer, there is a basic insulation label written in the nameplate of the transformer. So in this basic insulation label, whatever insulation tests of that transformer like lightning impulse test, switching impulse test with stand test have been done and at what voltage they have been done are written. Like you can see, this is a 145 kV transformer. And here the lightning impulse is 650 kV lightning impulse chopped wave your 715 kV and AC voltage is 275 kV. So in today's video we will try to understand what is the meaning of these terms written. If the full rated voltage of the transformer is 145 kV, then how do we test a transformer in 650 kV voltage test, and how do we do this test? So we will try to understand all these things in this video. So friend, first of all we will understand what we check by lightning impulse test. So friend, if any lightning occurs, suppose it is raining, cloudburst is happening, lightning is occurring, then the voltage of that lightning is much higher than the rated voltage of any transformer. In case of a transformer, the voltage of lightning can be 5 times, 6 times, 7 times more than the rated voltage of the transformer. But its phenomena of lightning are not of the type of normal transformer voltage. For example, if suppose lightning has occurred, then it occurs and goes away within microseconds. It does not sustain. It is not like that lightning stays in any system for 30 seconds or 40 seconds. So this is the phenomenon that we try to create when we test lightning impulse, and with this we check whether the insulation used in the transformer is able to sustain this lightning test or the lightning that will occur or not. Because if they are not able to sustain lightning, or if the insulation of the transformer is not able to sustain the high voltage even for a few microseconds, then the transformer can get damaged. There can be disturbances in the system. So next we understand lightning impulse. So friend, now we understood about lightning impulse. We understood about lightning. So based on the lightning phenomenon, whatever lightning occurs in our system due to cloudburst in our environment, we can divide it into 3 parts. The first one is full wave. So the friend of full wave means that lightning has occurred in a system and the lightning has fallen on the conductor. For example, if there is a conductor 1 to 2 kilometers or 1 kilometer away from the transformer, then lightning has come on the conductor and it has reached the transformer by traveling through the conductor. So you can see this in the graph here as well. What is here is that the voltage has increased due to the lightning and it has traveled through the conductor and then has come to your transformer. So this is what we call full wave lightning impulse. Next we understand what is chopped wave. So next is chopped wave. So, chopped wave means that the lightning has fallen on the conductor itself, and when the lightning was traveling, the high voltage was traveling through the conductor, then it damaged an insulator, and due to the damage to the insulator, that insulator got grounded. That means that the voltage has been chopped. So you can see in this graph that lightning I traveled and within 3 to 4 microseconds the voltage of lightning collapsed. So this is what we call chopped wave lightning impulse, and the next one is front of wave. So friend, saying front of wave means that the lightning has fallen directly on a transformer. So this is what we call front of wave lightning. So I hope you must have understood what are lightning full wave, chopped wave, front of wave. Next we understand friend, whenever we test lightning impulse, what are those instruments and how do we connect them? So whenever you see lightning impulse test instruments, they are very complicated. Because there we are developing high voltage. So here we get to see 3 things. The first one is impulse generator. The second one is multiplying chopping device, which we also call MCD. And the third one is voltage divider. So whatever impulse generators are there, we develop high voltage from impulse generator only. For example, if we have 245 or 220 kV transformer, then we have to apply 1050 kV voltage there. So we develop 1050 kV through impulse generator. Now you can see the photo of your kit on the right side here. So this is our impulse generator. So we apply voltage from here only. So how do we increase the voltage? Capacitors are fitted here. Registers are fitted, and the registers are also your front register and tail register. RF means front and RT means tail register. So here we set the timing from time that whatever voltage is there, that peak voltage should come in our 1.2 microseconds. And the 50% off peak voltage should come in 50 microseconds. So we set this through the register. Next is the multi-piping chopping device. So as I told you, what does chop voltage chopped impulse mean? That if we suppose we made our lightning travel for 3 microseconds. After that we collapsed the voltage, then we do that with the chopped multi-piping device. So you can see this instrument. This is the multiplying chopped device MCD. So here you have conductors, so we short it. As soon as 3 microseconds pass, we short it. So from here the voltage collapses. Next is the voltage divider. So with the voltage divider, this voltage divider steps down the voltage whatever voltage we applied, and with this we provide the input of our monitor crow where we want to see the graph. So I hope, friend, you have understood the instrument of lightning impulse and this circuit which I made, RF RTMCD and voltage divider. This is what we call the Gallinger circuit. Friend, next we understand that when we test lightning impulse, how do we connect it to a transformer? So friend, whenever we test lightning impulse, it is a very high voltage test. We also call it a destructive test. What does it mean? The more high voltage we apply, the more we are trying to degrade the insulation of the transformer. So we should do it in minimum number of times and follow whatever safety precautions are there. So, whenever we test lightning impulse, the first thing we have to keep in mind is that, except the phase in which we are testing lightning impulse, we have to short and ground all the phases, either primary or secondary, so that whatever inductance is there or whatever voltage is there, it does not go to other phases. So you can see that if we test lightning impulse in R phase, then we short and ground the Y and B phases on the star side and also short and ground all 3 phases on the delta side. Next, suppose here there is a 245 kV transformer, then we applied 1050 kV voltage through impulse generator. So we applied voltage from impulse generator and the voltage divider here, we gave it secondary to crow, where we will get graphs. In the same way, we are taking the reference of current from neutral, if we are doing it in the star side. So by taking the conductor of neutral, we have grounded the neutral through the shunt register, and from here we have given the input of current to crow or monitor. So this is how we do the connection for the test. Next we understand that if suppose we have to do lightning impulse from the delta side, then how will we do its connection? Same as I told you, that except the phase in which we are doing lightning impulse, we have to short and ground all the phases. Like you can see, we have shorted and grounded the star side or primary side, and here this is the R phase. So we are doing lightning impulse test in the R phase. Right now there is no neutral in the delta side. So what we do here is that we short the other 2 phases. By shorting the shunt register, we ground the shunt register, and through the shunt register we give the current input to the crow and the voltage input through the voltage divider. So this is the connection if we have to do lightning impulse from the delta side. Friend, we have now understood how to connect the lightning impulse test. Now it is very important for us to understand that when we do lightning impulse, now as I told you, we apply high voltage test. So how do we apply that high voltage test? For how much time do we apply? So according to IC 60076 clause 3. Friend, if you also see this IC standard, then what is the standard in lightning impulse? You will find how much voltage to apply. But suppose we have a transformer of 245 kilovolts, then according to IC we have to apply 1050 kV voltage. But how do we apply this 1050 kV voltage? So this pick is, suppose it is 1 unit. This pick of 1050 kV should come in 1.2 microseconds. You can see that this pick is T1, which we also call front time. This pick should come in 1.2 microseconds, and 50% of pick voltage is like 1050 kilovolts. then approximately 525 kV voltage, which we call tail T2, should come in 50 microseconds. So here IC tells us that there is some tolerance also, that this pick can be plus minus 30%, or the front time, and the tail time can be plus minus 20%. That means the tail time should come in 40 microseconds to 60 microseconds, and the pick, which is front time, should come in 1.2 microseconds plus minus 30%. So if this criterion is getting fulfilled, then we can say that we have given full wave lightning impulse to a transformer. So friend, you can see how the graphs of the real transformer come. So we did the lightning impulse test, and here are its graphs. And what we check here is that we check that the voltage that we gave for 1.2 front time tail time, the voltage should not collapse anywhere. If the voltage collapses, that means that the insulation provided in a transformer has not been stored with the lightning impulse test. So there should not be voltage collapses here. In the same way, corresponding to this, we also get the graphs of current. You can see how the variation of current is. Next friend, if we do lightning impulse, then how do we do it? You can also understand from this graph that whatever your 1.2 microsecond is has come in 650 kilovolts, and the 50%, that is 50% off voltage, has come in 50 microseconds. Friends, there is one more thing here, that when we test lightning impulse here, we apply negative voltage. What does applying negative voltage mean? That, like we apply high voltage here, for example, 650 kilovolts, 1050 kilovolts, then we apply negative polarity voltage, like minus, because whatever charged particles, ions, surrounding mediums, whatever particles are there in the air, all are negatively charged. So if we apply positive voltage, then positive negative ions can get ionized here, and whenever we apply voltage, there are chances of flashover in the bushing. That is why we apply negative voltage, so that negative and negative get repelled, and whatever flashover or collapse voltage chances are there, they do not happen. Next friends, we understand chopped wave lightning impulse. So whatever we just talked about, 1.2 microseconds, 50 microseconds front time, tail time, all that was full wave lightning impulse. So whatever is the connection between chopped wave and full wave, friend, all of them are the same. As we told in the beginning in the kit, that there is a chopping device which we call multiple chopping device, MCD. So what is here? In the chop way, we have to do that as soon as your time of full wave is 2 to 6 microseconds. Like we saw that a peak came in 1.2 microseconds. After that your voltage started reducing. So as soon as it is 2 to 6 microseconds, we have to chop the voltage there. That means the voltage has to be grounded. So what will happen here? Your voltage will directly become -0. So this is what we call chopped wave lightning impulse. So we have to keep in mind that whatever voltages are chopped in minimum time. So this is what we call chopped wave lightning impulse test. Next, friend, you can see this. This is a table. Lightning impulse test, in which voltage, how much voltage do you have to do? So you can see here. Suppose we have a 245 kilovolts transformer. So here given our lightning impulse test at 1050 kilovolts. Chopped wave, which is there, we have to do it at 1155 kilovolts. Switching impulse is 850 kilovolts, and AC voltage with resistance test is to be done at 460 kilovolts. In the same way, if you have a 145 kilovolts transformer, then 650 kilovolts lightning impulse, 715 kilobytes chopped wave lightning impulse, 540 kilobytes switching impulse, and 275 kilovolts AC voltage with resistance. So this table I have taken from IC 60076 clause 3. So you can go there and see. Here also these tables are given that if you have a higher voltage transformer than any distribution transformer. So at how many kV should we do the impulse test there? So friend, that's all about this video. I hope you have understood the lightning impulse test well, how to connect it. What is the sense? How do we do the test? So if you have any doubt you can ask in the comment section. So if you like the video friend, please like, share and subscribe. Thank you.